following that whole Crowdstrike incident knocking out 8.5 million Windows PCs around the globe, causing damages in the range of 1 billion, upwards of 5 billion. Now, obviously, that is a very big range, and there are many billions in between those gaps. But whatever the number ultimately was, it was a lot of money lost that day and the following days as technicians were trying to bring systems back online. But ultimately, CrowdStrike are the ones at fault for this happening. Now, I know some people want to blame all businesses that are running all on this same software and all centralized in this one location, so if anything goes wrong, they all go down. Yes, understandable, but at the end of the day, CrowdStrike are the ones that caused this to happen by shipping out software that frankly shouldn't have been shipped out, because it's very clear that their testing processes are not good enough or don't exist. However, Microsoft is still in a position where they are supplying a platform and corporate users have certain expectations of that platform, even if the problem they are having isn't necessarily caused by the platform itself. It's something that is popular to install on that platform. And Microsoft's Vice President of Enterprise and OS Security, David Weston, put out a recent post regarding this whole situation: Windows Security Best Practices for Integrating and Managing Security Tools. Now, most of this piece is basically a technical analysis of what went down with the CrowdStrike Falcon situation, basically what caused it, and I would really recommend reading it if you want to get up to speed on what went down and you have a fairly technical background. But I want to jump ahead to the part where we talk about this here. Why do security solutions leverage kernel drivers? I, like the rest of you, don't like these random kernel level pieces of software that obviously exist in the corporate space, but exist in the game space as well, with anti-cheat solutions and all of this fun stuff. Whilst the level of protection is different here, and the goals of what you're protecting is different, at the end of the day, they're still security solutions, so why do they do it like this? Visibility and enforcement of security-related events. To detect the rootkit, you must become the rootkit. Not the phrasing being used here, but basically what's being said. In addition, Microsoft provides a rich set of capabilities such as system event callbacks for process and thread creation and filter drivers which can watch for events like file creation, deletion, or modification. Kernel activity can also trigger callbacks for drivers to decide when to block activities like file or process creations. Again, what I was saying, if you're fighting against low-level software that has wide access to your system, you want to have even wider access to make sure you know everything it is doing. This comes with drawbacks, like if things go really badly, the entire system crashes, but hey, you know, you win some, you lose some. Performance. When you don't have to constantly jump back and forth between user space and kernel space, and you're doing everything in kernel space, you get rid of that overhead, which brings the performance way down. There are many scenarios where data collection and analysis can be optimized for operation outside of kernel mode, and Microsoft continues to partner with the ecosystem to improve performance and provide best practices to achieve parity outside of kernel mode. Tamper resistance. Again, to fight the rootkit, you must become the rootkit. You need to out-rootkit the rootkit, so the rootkit can't disable you. If the rootkit has lower level system access than you, well, how are you going to fight the rootkit if the rootkit knows you're there and can just turn the software off? It makes sense, right? They also want to ensure that their drivers are loaded as early as possible so they can observe system events at the earliest possible time. In the general case, there is a trade-off that security vendors must rationalize when it comes to kernel drivers. Kernel drivers provide the above properties at the cost of resilience, since kernel drivers run at the most trusted level of Windows, where containment and recovery capabilities are by nature constrained. Security vendors must carefully balance needs like visibility and tamper resistance with the risk of operating within kernel mode. And this is funny to read after the CrowdStrike situation. All code operating at kernel level requires extensive validation because it cannot fail and restart like a normal user application. This is exactly what CrowdStrike did not do. It is possible today for security tools to balance security and reliability. For example, security vendors can use minimal sensors that run in kernel mode for data collection and enforcement, limiting exposure to availability issues. The remainder of the key product functionality includes managing updates, parsing content, and other operations can occur isolated within user mode where recoverability is possible. This demonstrates the best practice of minimizing kernel usage while still maintaining a robust security posture and strong visibility. Do I need to mention CrowdStrike once again? Now, this is Microsoft's response following the CrowdStrike situation. But this is not the only time in very recent history they put out a blog post or a memo or some other document explaining their stance on security and things that probably need to be done or better handled. Back in May of this year, read Satya Nadella's Microsoft memo on putting security first. This was following a string of major attacks on Microsoft tech over the past couple of years. Chinese government hackers targeted Microsoft Exchange servers with zero-day exploits in early 2021, enabling them to access email accounts and install malware on servers hosted by businesses. Last year, Chinese hackers breached US government emails thanks to a Microsoft Cloud exploit. Recently, the same Russian state-sponsored hackers that behind the SolarWinds incident, known as Nebelium or Midnight Blizzard, were able to spy on email accounts of some members of Microsoft's senior leadership team last year and even steal some source code earlier this year. Whilst the CrowdStrike situation wasn't necessarily a security issue, more of a stability and best developer practice issue, many of these same issues apply to both situations. Now, accompanying this internal memo, Microsoft also released a publicly facing blog post talking about much of the same information. Security above all else, expanding Microsoft's Secure Future initiative. But let's have a look at the memo itself. Microsoft runs on trust, and our success depends on earning and maintaining it. Trust is a currency in relatively short supply, especially as of late after the recent incident. We have a unique opportunity and responsibility to build the most secure and trusted platform that the world innovates upon. Last November, we launched our Secure Future initiative, SFI, with this responsibility in mind, bringing together every part of the company to advance cybersecurity protection across both new products and legacy infrastructure. I'm proud of this initiative and grateful for the work that has gone into implementing it, but we must and will do more. Going forward, we will commit the entirety of our organization to SFI as we double down on this initiative with an approach grounded in 3 core principles. Okay, secure by design. Security comes first when designing any product or service. Now, I first talked about this post following that whole Microsoft recall situation where it was very clearly demonstrated that the data was not being handled securely, let alone the fact that data was being collected, right? If the data was being collected and it was very, very safely being handled, fine. But it was very easy to just look at the database with a database viewer and exfiltrate all of the data. Secure by default. Security protections are enabled and enforced by default, require no extra effort, and are not optional. Secure operations. Security controls and monitoring will continuously be improved to meet current and future threats. This is the vaguest of vague statements that's ever been vagued. We must approach this challenge with both technical and operational rigor, and with a focus on continuous improvement. Every task we take on, from a line of code to a customer or partner process, is an opportunity to help bolster our own security and that of our entire ecosystem. This includes learning from our adversaries and the increasing sophistication of their capabilities, as we did with Midnight Blizzard. That is honestly like a really, really cool name for a group. I think that's amazing. And learning from the trillions of unique signals we're constantly monitoring to strengthen our overall posture. That's a really nice way to frame collecting all of your data trillions of unique signals we're constantly monitoring to strengthen our overall posture. It also includes stronger and more structured collaboration across the public and private sector. And this is the most important part. If you're faced with the trade-off between security and another priority, your answer is clear. Do security. In some cases, this will mean prioritizing security above other things we do, such as releasing new features or providing ongoing legacy support for systems. This is key to advancing both our platform quality and capability such that we can protect the digital estates of our customers and build a safer world for all. Whilst Microsoft may not provide the best legacy support in the way of hardware, when it comes to software support, that's a whole nother story. There are a lot of businesses out there that are running really, really old code because it just works. Like, they don't want to pay for something new. They don't have to pay for something new. So we made this software during DOS, and it kind of still probably works well enough. Let's just keep going with it. Oftentimes also not by choice because they weren't provided the source code for it, they just bought a software package, and in cases where they do have the source code, it may be legacy spaghetti code that nobody wants to touch anymore and they don't want to pay anyone to deal with. Now sure, this post is unrelated to the CrowdStrike situation, but much like the whole thing with Mozilla, where a month after buying an ad tech company, you have the whole, deploying the privacy-preserving attribution thing, the timing on this is very, very amusing. And you know what's also amusing? Whilst I do think CrowdStrike is ultimately the ones at fault for doing everything wrong here, some companies don't necessarily agree. Delta is going after both CrowdStrike and Microsoft for damages after the outage. I know that US senators were also calling for a hearing, and I wouldn't be surprised if other companies also decide to go after them. Whether they are successful in getting damages is another question. Whether the courts determine that Microsoft has any fault here, or if it's all entirely on CrowdStrike, or even if CrowdStrike can get away without paying any damages, we'll have to wait and see. But whilst the technical side of CrowdStrike is over, CrowdStrike itself is certainly not done. The whole debacle about CrowdStrike is certainly not over, and there's a lot more to still talk about. But what do you think? Where do you think this is going to go? Do you think the CrowdStrike is actually going to have to pay damages? Do you think Microsoft is going to have to pay damages? And do you think that Microsoft really cares about making sure that their third parties don't do really stupid things? I would love to know. So if you liked the video, go like the video. And if you really liked the video and you want to become one of these amazing people over here, check out the Patreon, Scribes, LiberaPay, linked in the description down below. That's going to be it for me, and it's probably best just to, not be involved with CrowdStrike anymore.